Lesson 10.17 is finding holes algebraically. So how to find a hole in a function. You're going to factor completely, top and bottom. Any canceled factors will form the hole. So we've been talking about it a little bit, but we haven't used it yet. Set the canceled factor, or it could be more than one, equal to 0 and solve for x. This is your x value of the hole. Plug this x value into the simplified function and solve for y. So what this is saying is sometimes when we graph functions, even ones that look linear, could have a spot where at that x value, there's actually not a point. That's what we're trying to find. That's just a number sign. Okay? It'll make more sense once we get a couple lessons after this and actually graph. So I did the wrong. Find the holes of the following functions and write them as a coordinate point. Okay, so first job factor, take out 2, it'd be times x minus 10. On the bottom, slide and divide. What is that? Be 14 and 5. No, because it has to be negative. Hold on. No, that's right. Sorry, brain fart. Yeah. Okay. Ooh, good. Divided by 2. So that would be x plus 7. And that would be 2x minus 5. Okay, so we factored. I don't have any factors that cancel. So that right there tells me there's no holes. So those are the easy ones. No canceled factors mean that there's no holes. All right, number 2. Let's factor. We've got another slide and divide here. Nine and 4. Negative 9. Positive 4. Oh, I didn't divide. Shoot. I'll just do it right here. Divided by 3. That'd be x minus 3 times 3x plus 4. Okay, on the denominator, factor that. That'd be negative 3 and negative 1. Okay, so right here, the x minus 3's are the factor that cancels. You take that factor, set it equal to 0, and figure out what x would be to make that 0. So you'd add 3, so x is 3. That is then the x coordinate of the hole. Then what you do is plug 3 back in. You could do either, no, you can't do because it makes it 0, but you need to plug it back into the simplified function, which is this. Let me switch colors. So with that hole gone, we have the function 3x plus 4 over x minus 1. I'm going to plug in 3. So that would be 3 times 3 is 9. Oh my goodness. Plus 4. Is 13, and then 3 minus 1 is 2. So we get 13 halves. You can leave it like that. You could make a decimal if you wanted. 12 divided by 2 would be 6, so that'd be 6.5. But that is the point. Think about on a graph, that would be at 1, 2, 3, up 1, 2, 3, 4, 5, 6.5. There's some kind of hole there with whatever our function is doing. Okay.